Okay, so today we're going to be looking at the synapse. The synapse is the name given to the process by which we move an electrical current from one neuron to another, because the nervous system is all about pathways. Forming pathways, maintaining pathways. Pathways are, the endpoints of all these pathways are where our memories are stored, um, and our behaviors, our thoughts, all these things are pathways through our brain. And being able to form them and maintain them is really important. So, what is a synapse? It is a site where a neuron makes a connection with either another neuron or an effector, muscle, or gland. Okay, so the simplest type of synapse is, of course, not the one we find commonly in humans because it's a simple, as I said, synapse, and that's where the cell membranes, they just touch each other. They're in direct contact. So the one neuron is in direct contact with the other, or the neuron is in direct contact with the muscle or the gland, and the electrical current just flows from one to the other. This is really fast, but not common. So if you want to look at the synapse, this picture shows it really well. So you can see right here, you're looking at the axon terminal of one neuron, so neuron number one, and the dendrite of neuron number two. Now the thing you should notice is it's not quite touching. So this picture is not showing an electrical synapse because an electrical synapse, as I said, is not common in humans. They're fast, but they're not selective. We are much more complex than an electrical synapse would allow for. Electrical synapses are common in very simple organisms. Um, we do not want all our pathways to conduct electricity every time there's a stimulus. We want to be selective. So we want pathways, actually, most pathways, to be inhibited, not stimulated. So I'll give you an example of what I mean when I say that. When I say the words chocolate chip cookies, everyone's going to have different thoughts or feelings slightly when I say that. Um, so maybe some people immediately their mind went down the pathway of visualizing what a chocolate chip cookie looks like. Maybe you had a homemade chocolate chip cookie last night, so you're going to that memory, or you're thinking about the taste of it, or you went through pathways thinking, "Gee, I'm kind of hungry. I haven't had breakfast yet." Whatever pathways you went down, when I said that, there were many more that were inhibited, not stimulated. And I know that because all your pathways were not stimulated at the same time. Otherwise, you would be doing things like chewing, even though you don't have, have chocolate chip cookies in your mouth. You would start salivating. Your digestive system would start preparing for the incoming chocolate chip cookie. Every thought, every feeling, every behavior associated with chocolate chip cookies would be happening right now, but they're not, because we have more complex synapses that allow things like inhibition to happen, which is just as important, if not more important, than stimulation of a pathway or a neuron. Okay? So they're fast but not common. And so here is the type of synapse we actually have. So what we're doing is we're just blowing up one of these pathways that go from an axon terminal to a dendrite. We're going to look at it. And you should notice here that we have a space in between those two neurons, okay? The space between them is called the synaptic cleft. And the fact that there is a synaptic cleft means this is a chemical synapse, okay? So chemical synapse is fluid-filled space between neurons where neurotransmitters, these are chemicals, rapidly diffuse through to the postsynaptic membrane. Okay, so it allows input from thousands of axon terminals, is slower, but also allows options like inhibition as well as stimulation or action potential in the next neuron. So if we look at this diagram, your axon terminal is number 1. So that is from the first neuron. That's the end of that neuron. And we also refer to the end point of that neuron as the postsynaptic membrane. It comes before the synapse. Then we have the cleft, the synaptic cleft, and then we have number 4, the postsynaptic membrane. So that is the dendrite of the next neuron. So into the dendrite, out of the axon terminal. So a chemical synapse can be recognized by that space between the two. Okay, so how do we start an action potential in this dendrite? How do we start the electricity being conducted? Okay, well, if you remember, how does electricity start to be conducted in any dendrite? It doesn't matter how the dendrite is being stimulated. So remember, dendrites can be stimulated by light with photoreceptors being embedded in them. They can be stimulated by pressure. They can be stimulated by pain. They can be stimulated by all kinds of things. They can be stimulated by chemicals at a synapse. Okay? And so if we want to conduct electricity in this specific neuron, we have to do step number 1 of conducting electricity, which, if hopefully you remember, is we need to open sodium channels. Okay, so how do we open sodium channels? We open them with chemicals. That's what neurotransmitters do. They open sodium channels. So, this diagram will, is a great little diagram that's showing, here is your presynaptic membrane, which is the axon terminal of one neuron. And here is the postsynaptic. So that is a dendrite. Okay, so what happens here is there's multiple things that are going on that will cause this action potential in the next membrane. It starts with an action potential in this specific neuron in the presynaptic membrane. So an action potential has worked its way through this membrane or through this neuron. Okay. So we have an action potential moving down. As it approaches the... Oh, nice. Erasing stuff here. As it approaches the axon terminal, the electrical current moving through will open sodium channels. Or sorry, calcium channels. Will open calcium channels. Okay, so that is stimulated by the electrical current. Remember, these channels can be regulated. They can be opened and closed, and they can be regulated by all kinds of different things. In this case, it's being regulated by an electrical current or voltage moving through. So when the calcium channels, which we haven't talked about yet, but here they are, they're calcium channels. When these gates open due to an action potential, it will cause an influx of calcium. And that causes vesicles. Remember, vesicles are made of up of that lipid bilayer. You got to think way back to our first unit where we talked about the different organelles and their function. So vesicles store substances in them. In this case, they store neurotransmitters. And the influx of calcium causes the movement of those vesicles containing neurotransmitter to move to the cell membrane. And when those vesicles get to the cell membrane, and hopefully you remember how this all works with the lipid bilayer surrounding or making up the vesicle and the lipid bilayer in the membrane, those two things will fuse together and we will get that process called exocytosis. So the neurotransmitter will be released into the synaptic cleft and it is going to bind to these channels below. Okay? And so what do you think when the neurotransmitter binds to those channels, what do you think it's going to do? What action do you think it's going to happen? So if you were thinking, well, it's got to open sodium channels because we need an action potential in the next neuron, you're correct. It has to open sodium channels. So those neurotransmitters will open sodium channels if we are trying to get the action potential to move to the next neuron. So we want to stimulate as opposed to inhibit. So it will open those sodium channels. The neurotransmitter will change the shape of those channels, cause them to open, and the sodium, which is always, in abundance around these neurons, will flow in. Okay? So I always like to talk about how, we want to synapse, especially in school. So, you're writing your exam, you're writing a test. What you're trying to do is synapse or get the electricity down those pathways to find the memories of the concepts you've learned. Okay? So when we talk about learning things, using concept maps, making connections between concepts. This is really important because if you have a lot of connections regarding a concept, there's so many different pathways to get to that endpoint or that memory that you're way more likely to find it, as opposed to just straight memorizing one concept, right? If you have multiple pathways to get there, you're more likely to get there. So your goal when you're learning is to make pathways and then reinforce them, or make sure you synapse all the way through to find that memory. So how do you ensure that you synapse? What is the key to synapsing all the way through the right pathways, or learning? What is the key to learning? Well, because the key to learning is the synapse, and the best way to synapse is to have multiple pathways, make lots of connections between concepts. So you want to make connections between our first unit, where we talked about vesicles, where we talked about exocytosis, all these things. If you remember these things and you connect them to your knowledge of a synapse now, you're far more likely to remember the concept of a synapse. But another way to ensure you synapse is you want to make lots of vesicles that contain neurotransmitter, right? The more vesicles containing neurotransmitter, the more likely you are to have enough neurotransmitter to open the sodium channels and move down that pathway. So how do you ensure you do that? How at the cellular level do you ensure you're going to synapse, that you've got enough neurotransmitter? And unfortunately, it's not easy, because like everything else, the best way to make more neurotransmitter and more vesicles to synapse is to use that pathway over and over again. The more you use the pathway, the more neurotransmitter you're going to make. The more vesicles with neurotransmitter you have, the more likely you're going to get those sodium channels open. So repetition is how we do this, okay? By forcing the pathway to be used over and over again. It reinforces the pathway, it increases the amount of neurotransmitter, and it makes the synapse happen down that pathway, because we're going to need to synapse multiple times, multiple times to, to understand concepts. So there are two things you can do here to ensure you synapse during tests, exams, assignments. Okay, one is repetition. Okay, but the other is connecting, is connections. Okay, connecting ideas. Because the more pathways you have leading to an endpoint, the more likely you are to get to that endpoint, because it gives you options. So repetition and connecting ideas. Some people and typically in biology, we spend way too much time memorizing or doing this repetition and not enough time doing the connections. We're trying to move away from that. And I like my students to move away from that, because this connecting ideas just works so much better, right? The repetition works, but it tends to be a lot more short term. But anyway, no easy way, but if you want to synapse connections, connect your thoughts, connect your ideas to previous knowledge. Just get more pathways going, and then repetition. So once we get to that end point, this is just a little blow up of the dendrite on the postsynaptic neuron membrane on that second neuron. So it's just showing you what happens here. The neurotransmitter that was released from the vesicle in the first neuron will bind to the channel, change its shape, and allow that flow in. Open the sodium channels. In goes the sodium. And again, once we change that voltage away from negative 70 millivolts in this second neuron, move it up to the negative 50, which is the threshold. Boom, we'll get an action potential moving down that one. Okay, so I would just, write these notes in. Hopefully you printed up this little PDF, and you can just write on it and highlight. And I'm also going to, there's a few little animations here. I will add them on to the lesson. And just make sure your flash is enabled, and you'll be able to go and take a look.